In this installment, we're going to take another look at what we've looked at many times already, which is an Atwood's machine, or a modified Atwood's machine. This one's a little more sophisticated than what we've seen before, but it basically comes down to static equilibrium. If we draw the free body diagrams for all of these objects, we have M1 with its Fg1, and we'll call this the force of tension 1. Then we've got M2, which has the force of gravity of 2 and the force normal. And there is a force of tension 2 and a force of tension 3. And then we look at mass 3. There is Fg3 and the force of tension 4. Now, what we've said before is we want to write these all out in one line because the pulleys transform them. So we have Fg1 and Ft1. And we have Fg2 and Fn, Ft2, Ft3, and lastly over here we have Fg3 and Ft4. Now, what we've said in the past, we've studied tension, and we realized since none of the molecules in this cable, none of them is accelerating from each other, that means the forces must be balanced everywhere inside that cable. So when we write out a horizontal Newton's second law expression, we have the net force equals the sum of the forces, MA. And the sum of our forces we have are minus Fg1 plus Ft1 minus Ft2 plus Ft3 minus Ft4 plus Fg3. And what we said was this Ft3 and this Ft4 are equal and opposite to each other. And this Ft1 and Ft2 are equal and opposite to each other. So we're left with MA is minus Fg1 plus Fg3. And the mass of the system is M1 plus M2 plus M3 is going to accelerate. And this is minus M1G plus M3G. We could rewrite this expression by factoring out the G. M3, that's minus M1 plus M3, or M3 minus M1. And then we can express the acceleration as G times M3 minus M1 all over M1 plus M2 plus M3. So that's what the acceleration is. Now we're told that the velocity is 0. If mass 1 has a mass of 1 kilogram, mass 2 has a mass of 2 kilograms, and mass 3 has a mass of 2 kilograms, well, ultimately it comes down to this mass and this mass. This thing should accelerate. Basically, this M1 is holding up this M3. For that to be the case, for the velocity need to be 0, there must be some force stopping it, and that force would be a frictional force on M2. So this can happen as if there is friction on mass 2. Otherwise, this is a straightforward Atwood's machine straightforward double modified Atwood's machine, and the whole system should accelerate to the right because this has more mass than this. It doesn't, which means there must be an additional force, and that could come from the friction. And what if mass 3 is 5 kilograms? How would we explain that at rest? Well, explaining that at rest, again, would be by having friction. By having friction.